In this question, it is given that f takes the interval 0 to infinity to the interval 0 to 3 be a function defined by fx equal to maximum of sine t where t lies between 0 and x lies between 0 and pi, and fx is 2 plus cos x if x is greater than pi. Then which of the following is true? You have to find the correct choice. First is f is continuous everywhere but not differentiable at exactly one point in the interval 0 to infinity. Second, f is differentiable everywhere in the interval 0 to infinity. Third, f is not continuous exactly at 2 points in the interval 0 to infinity. And fourth is f is continuous everywhere but not differentiable exactly at 2 points in the interval 0 to infinity. The only difficult part of this question is to redefine the function fx. That is, in the difficult part, only this part is a bit difficult to redefine. First, let me explain this. Suppose you have to find the value, say, at pi by 3. The question says that I will make t vary from 0 to pi by 3, and all the values of t I will put here, and I will get infinite number of answers after putting the value of t from 0 to pi by 3. Out of those infinite number of answers, the maximum answer will be the value of f pi by 3. In this way, you have to find the value of fx for every value of x from 0 to pi. And after pi, it is very simple. It is always 2 plus cos x. To redefine this function, I will have to draw the graph of sine t, and because the maximum value of t which I can take is pi, and that will be there when the x is equal to pi. Hence, I draw the graph of sine t where t varies from 0 to pi. First, let me draw the graph of y equal to sine t. And because the maximum possible value of x is pi, therefore I will have to make t vary from 0 to maximum pi. And this is the graph of y equal to sine t. Here it is pi, here it is pi by 2, it is 1, pi by 2 comma 1. Suppose the value of x is pi by 3. Then according to this information, I will have to make t vary from 0 to pi by 3. That is, as t vary from 0 to pi by 3, from this part of the graph, it is clear that y coordinate of all these points are different values of sine t as t vary from 0 to pi by 3. Note that here I have taken x as pi by 3. And it is obvious that when t is pi by 3, at that time the value of sine t will be maximum. And the situation will remain same because when x is less than pi by 2, wherever x is there, at the last point, the value of sine t will become maximum. But once x has crossed pi by 2, say here, then out of all the y coordinate of these points, the maximum value of sine t will be always 1. That is, this situation will be there whenever x lies between pi by 2 and pi, because for all these values of x, whenever t will vary from 0 to x, out of all these y coordinates, the maximum y coordinate will be at this point. That is, maximum y coordinate will be 1. Hence, in a redefined form of fx, this part will be broken into two parts. For 0 less than equal to x less than equal to power 2, and when x lies between power 2 and pi. Note that power 2 I have taken at both the places, no problem, because at power 2 in both the cases the value of f power 2 will be same. As I just now explained, so far as x is less than power 2, the maximum value of sin t is always at x. Hence, in this case, the value of this will be sin x. And I told this thing also, if x has crossed pi by 2, as t varies from 0 to x, the maximum value of sin t will be 1 always. Hence, redefined form will be 1. Hence, I conclude that fx is equal to sin x if 0 is less than equal to x, less than equal to pi by 2. 1 if x lie between pi by 2 and pi. And from here, 2 plus cos x if x is greater than pi. Note that at pi by 2, both have given same answer. And now we have to discuss the continuity and differentiability in the interval 0 to infinity. It is clear that between 0 and pi by 2, fx is sin x and sin x is always continuous function. Between pi by 2 and pi, it is constant function, hence continuous. For x more than pi, because cos x is always continuous, hence 2 plus cos x is also always continuous. And because the function is changing only at pi by 2 and pi, hence discontinuity or non-differentiability, if it is there, then that can be only at pi by 2 or pi. It is clear that left hand limit of fx at pi by 2 will be 1. Value of function at pi by 2 is also 1 from here or here. Right hand limit at x equal to pi by 2 is also 1. Hence the function is continuous at 1. And at pi, value of function is 1. Left hand limit is also clearly 1. Right hand limit will be 2 minus 1, that is 1. Hence at doubtful points also the function is continuous. That is, I can say the function is always continuous. And now to discuss about the points of non-differentiability, it is clear that because sin x is always differentiable, between 0 and pi by 2, sin x is clearly differentiable. Between pi by 2 and pi, constant function, hence differentiable. For x more than pi, again because cos x is always differentiable, 2 plus cos x is always differentiable. Hence, non-differentiability, if it is there, then that can be only at pi by 2 or pi. Now let us discuss the differentiability at pi by 2 and pi. For pi by 2, to find the left hand derivative, I will not be using the proper formula because it is easier to use the shortcut way of finding the derivative of fx at pi by 2. And the shortcut way you must have learnt while preparing for JEE, and by shortcut way I can easily say that left hand derivative at pi by 2 will be limit x tends to pi by 2 minus, and I will write the derivative of this, that is cos x. This is f dash pi by 2 minus, and this is 0. Similarly, f dash pi by 2 plus is limit x tends to pi by 2 plus, and here I will write the derivative of this, and 0, that is 0. Hence at pi by 2 because left hand derivative and right hand derivative both are 0. Hence I can say fx is differentiable at pi by 2. And now to discuss about the differentiability at pi, that is f dash pi minus, that is limit x tends to pi minus derivative of this is 0, hence the answer is 0. Similarly, f dash pi plus will be limit x tends to pi plus, and here I will be writing the derivative of this, that is minus sin x, that is 0, hence the function is differentiable at pi also. Hence there is no point of discontinuity and no point of non-differentiability. Hence I can say B is the correct choice.